Thrust and pressure. Have you ever wondered why a camel can run in a desert easily? Okay, we know it very well that camel can run easily in a desert area. Okay, why an army tank weighing more than 1,000 tons rest upon a continuous chain? Okay, in a continuous chain, how the tank are resting as well as how it work. Okay, why a truck or a motor bus has much wider tire? Okay, if we talk about the truck and motor bus, then also we can see that the tires are so much bigger or larger as compared to a other vehicle. Okay, why cutting a tool have a sharp edge? In order to address this question and understand the phenomena involved, it helps to introduce the concept. Okay, now we will talk about a new concept in which we will study how wideness as well as sharpness work. Okay, and how the pressure exerted to a particular surface. Okay, of a net force in the particular direction, okay, which we say it as a thrust. Okay, thrust means what? A net force exerting in a particular direction or limited area, and the force per unit area, which we say it as a pressure, okay, acting on an object concerned. Okay, let us try to understand the meaning of a thrust and a pressure by considering the following situation. Okay, now we will take a different situation, and depending upon that we will study about the thrust as well as pressure. Okay, you wish to fix a poster on a bulletin board, okay, as shown in figure 10.3. Okay, we will see in the next slide. Okay, to do this task you will have to press a drawing pin, okay, with your thumb. Okay, with our thumb we have to press a drawing pin, and we are doing, okay, in class also. Okay, if we want to picture, if we want to picture a picture in a bulletin board, then what we are doing, we are taking a pin, okay, which we say it is a drawing pin, and with the help of that drawing pin we are, okay, pressing that pin inside the bulletin board, and due to which it will be settled. Okay, so in this phenomena also thrust is working as well as pressure is working. Okay, you apply a force on the surface area of the head of a pin. Okay, we are exhibiting a pressure. Okay, we are giving a pressure or applying a pressure or a force, okay, upon selected area only. Okay, we are giving a force in a area of a head of a pin only. Okay, at the head of a pin we are giving a force. Okay, this force is directed perpendicular to the surface area of a ball, and which is what? Okay, it is the perpendicular with the surface area of a board. Okay, you can also see that the force which we are giving is perpendicular to the surface area of a board, and this force act on a smaller area of a tip of the pin. Okay, and the force which we are exerting that are a limited area only, which is the tip of the pin. Okay, in the tip of the pin only the force is applying, okay, which are smaller area. Okay, so here you can see that we are, okay, giving a force, okay, to the head of a pin or a tip of the pin only. Okay, so in the second situation you can see that you stand on a loose sand. Okay, if we are standing on a loose sand, what we are saying, your feet go deep into the sand. Okay, our feet will go inside that area. Now lie down on the sand. Okay, now what we are doing, we are lying down on the sand. You will find that your body will not go that deep in the sand. Okay, once again I am repeating, in the first case what we are doing, okay, we are standing. Okay, we are standing on a loose sand, okay, what we are saying that our feet go deep into the sand, okay, into the sand our feet will go deep, okay, while same way, okay, now we are what doing, we are lying down on that sand, okay, the sand are same, but now in this case what will be, we are lying down on the sand, okay. So in this case you can see that when we are standing, okay, the surface area was small, okay, because our feet area is smaller as compared to our whole body area. Why? Because on lying down we are increasing a area, okay. So you can see that you will find that your body will not go that deep in the sand. In both cases the force exerted on the sand is the weight of your body, okay. In the both the case you can see that, okay, sand are exerting a force of our weight only, okay, but the difference is that, okay, in the first case, okay, when we are standing at that time our area, okay, area which is our feet area, okay, feet area, on that limited area only whole body weight are exerting, okay, while on lying down, okay, we are increasing our surface area, okay, but the weight are same but it is divided in the different area, okay, why we are lying down on the sand. So from that we can see that, okay, when we are lying down on the sand our whole body area, okay, are exerting a pressure or a force, okay, on the loose sand, okay. So in this case you can see that when we are standing at that time a surface area was small, but when we are lying down at that time our whole body are considered as a surface area, okay. So you have learned that weight is the force acting vertically, okay. So weight is what, okay, force acting vertically downward, okay, it is vertically downward exerting force, okay. So here the force is acting perpendicular to the surface of the sand, okay, here you can see that force is acting where, okay, perpendicular to the surface of a sand. The force acting on an object perpendicular to the surface is said to be a thrust, okay. What we are saying, when a force acting on an object perpendicular to the surface, okay, okay, from the surface it is perpendicular acting force, and that force is said to be a thrust, okay. What we are saying, that is our thrust, okay. Once again I am repeating, a force, okay, a particular force which are acting on an object, okay, or a substance, okay, perpendicular to the surface is called thrust, okay. Force which are acting perpendicular to the surface of a object, okay, are said to be a thrust. When you stand on a loose sand, the force, that is the weight of your body, is acting on the area equal to the area of your feet, okay. So which we have already discussed, that when we are standing at that time our feet area is considered as a force acting area, okay. When you are lying down, okay, the same force acting on an area equal to the contact area of your whole body, okay. But in the second case, okay, which we have already discussed, that when we are lying down on the sand, okay, at that time what we are saying, that our whole body area are considered, okay, are considered as force acting area, okay. So which is larger than the area of your feet, and which is already what, okay, which is larger as compared to our foot area, okay. And that we also know it, that our foot area is smaller as compared to our whole body area, okay. Thus the effect of the force of a same magnitude on the different area, okay, the effect of force are same. Why? Because when we are standing at that time also our whole body weight are acting, or a force are acting on that particular sand area, okay. Same way, okay, when we are lying down at that time also our weight is acting on that sand, okay. So in the above cases thrust is the same, okay. Thrust is what, okay, thrust is the same, but the effect of the different, okay, effect are different. Therefore the effect of the thrust depend on the area on which it acting, okay. So effect are what, okay, thrust effect, okay, are depend on whom, okay, area on which it is acting. The effect of the thrust on the sand is larger while the standing that while lying, okay. The thrust on the unit area is called pressure, okay. So from that we can say that thrust on a unit area is called pressure, okay. Thus our formula will be pressure is equal to what? Thrust upon area, okay. Our formula will be thrust upon area, okay. Pressure is equal to what? Thrust upon area, okay. Same way, substituting the SI unit of the thrust and area in equation 10.20, okay, we will get a SI unit of a pressure, okay. If we talk about the thrust, which is a one of the force, okay, so its unit will be N, and area, okay, which will be in a meter square, okay. So our SI unit will be Newton per meter square. And same way, if we take it in a denominator, take it in a numerator, okay. So denominator are coming to a upward direction, okay. So it will come to a numerator, and due to which, okay, its area will SI unit will be Newton per meter square, okay. Here we are taking a denominator to a numerator, okay. So it will be Newton per meter square. In honor of a scientist Blaise Pascal, the SI unit of a pressure is called Pascal, okay. So SI unit of a pressure is also said to be a Pascal, and it is denoted by PA. Let us consider a numerical example to understand the effect of a thrust acting on the different area. Now the first example is a block of a wood is kept on a tabletop, okay. The mass of the wooden block is 5 kg and its dimension are 40 centimeter and 20 into 10 centimeter, okay. So find the pressure exactly, okay. In the first case you can see that 20 and 10 are there, okay. When it is in a standing position, while it is in the B, you can see that it is in a lying position, okay. So it is by the wood block on the tabletop if it is made to lie on the tabletop with its side of a dimension, okay. The first dimension is 20 centimeter into 10 centimeter, second is 40 centimeter into 20 centimeter, okay. So the mass is 5 kg, okay. Here you can see that mass is how much? Okay, 5 kg, which is already given, okay. So the dimension will be 40, 20 and 10, okay. Here the weight of the wooden block applies a thrust on the tabletop, that is F is equal to what? Okay, mg, okay. We know it very well, okay. Formula F is equal to mg, okay. And m, which we know it 5 kg, and g, which is 9.8 meter per second square, okay, universal constant, okay. So 49, okay, acceleration due to gravity small g, which is 9.8, and mass, which is 5 kg, which is already given, okay. So from that we are getting F is equal to 49 Newton, okay, 49 Newton. And same way, if we want to consider the area, okay, so just now we are calculating for the first case, okay. In the first case it was 20 centimeter and 10 centimeter, okay. So our area of side will be 20 into 10, okay. So it will be 200 centimeter square, okay. Now if we convert it into a meter square, okay, it will be 0.02 meter square, okay. Now we have a formula. P is equal to what? Okay, P is equal to thrust upon area, okay. Here thrust means what? Okay, force which are acting, which is 49 upon 0.02, okay. On simplifying that, okay, we will get 2450 Newton per meter square, okay. So for the first case we have find our pressure, which will be 2450 Newton per meter square. Now if we talk about the second case, in the second case our area which are given is 40 centimeter and 20 centimeter, okay. So substituting that value, okay, for the area, we will get, okay, 800 centimeter square. Okay, now if we convert it into meter square, okay, we know it very well that it will be 0.08 meter square. Okay, so centimeter square is converted to a meter square. Okay, so same way, okay, which we have already applied in the first step, okay, or a first case. Okay, 49 upon, now in this, okay, area will be how much? 0.08. Okay, so it will be 612.5 Newton meter square, and the pressure exerted by the side 20 centimeter into 10 centimeter, okay, which we have find will be 2450 Newton per meter square. Okay, 2450, and by the side 40 centimeter and 20 centimeter, it is 612.5 Newton meter square, which will be 612.5 Newton meter square, okay, per meter square. Okay, so thus the same force acting on a smaller area exerted a larger pressure. Okay, what? Okay, in a small area, okay, it will exert a larger pressure. Okay, the force are same in the both the cases, but you can see that in a smaller area larger will be the pressure, and a smaller pressure on a larger area. Okay, so if the area is larger, okay, the pressure will be less. Okay, this is the reason why a nail has a pointed tip, knife have a sharp edge, and building have a wide foundation. Okay, so pressure in fluid. Now the second topic is our pressure in a fluid. All liquid and gases are fluid. A solid exerted pressure on a surface due to its weight. Similarly, fluid have weight, and they also exert a pressure on the base and the wall of a container in which they are enclosed. Okay, if we talk about the liquid, okay, they also exert a pressure. Okay, but where it is exerting a pressure on a container wall. Okay, so pressure exerted in any confined mass of a fluid is transmitted undiminished in all direction. Okay, in all the direction you can see that it will be undiminished. Now beyond C. Okay, have you ever had a swim in a pool and filled a lighter? Okay, whenever we are swimming in a pool, we will feel a lighter. Okay, have you ever drawn a water from a well and feel that a bucket of a water is heavier when it is out of the water? Okay, whenever we are seeing, okay, when we are, okay, drawing a water, okay, from the well, okay, at that time we can see that when the bucket is under the water, okay, at that time its weight is less. Okay, but when it come outside, okay, from the water, okay, at that time we felt that a bucket to have a higher or a heavier weight. Okay, so have you ever wondered why a ship made of a iron and steel does not sink in a sea water? Okay, but whether the same amount of iron and steel in the form of seed will sink. Okay, so this question can be answered by taking a buoyancy in the consideration. Because of the buoyancy, okay, ship cannot able to sink because of their structural illustration. Okay, so its structure is different. Okay, so because of their structure, okay, buoyancy is applied on that ship, and ship cannot sink. Okay, so let us understand the meaning of buoyancy by doing an different activities. The force due to the gravitation, force due to the gravitational attraction of the earth act on the bottle in the downward direction. Okay, so the bottle is pulled downward. Okay, so the force due to gravitational attraction of the earth act on the bottle, okay, is in the downward direction. So the bottle is pulled downward, but the water exerted an upward force on the bottle. Okay, water will exert a upward force on the bottle, thus the bottle goes upward. Okay, so if we talk, okay, we have, okay, putting a bottle on a limited area of water, what we are saying, okay, it will not sink. Okay, we have learned that a weight of an object in the force due to gravitational attraction of the earth, when the bottle is immersed, the upward force exerted. Okay, whenever a bottle is thrown in a water area, at that time we can see that bottle is exerting a pressure in a downward direction, but a water will exert a pressure in a upward direction. Okay, so by the water on the bottle is greater its weight. Okay, so therefore it rise up when released. Okay, so force exerted, upward force which are exerted by the water. Okay, water are exerting a force on the bottle is greater. Okay, if we talk about that, okay, so first, water is exerting a gravitational force, okay, which is in a downward direction, but water is exerting its own buoyancy force, which we say it is a buoyancy force, which is in a upward direction, okay, which is in the upward direction. Okay, so here you can see that water force is greater as compared to a bottle. Okay, water force is greater as compared to a bottle. So due to which bottle will not sink, okay, in that water. Okay, so therefore it rise up and when release. Okay, so keep the bottle completely immersed. The upward force on the bottle due to water must be balanced. Okay, this can be achieved by externally applied force acting downward. This force must at least be the equal to the difference between the upward force and the weight of the bottle. Okay, the force should be what? Okay, force should be sufficient that it can attract a upward force. Then and only then it can be sink. Okay, if a object have to sink in a water, then first, okay, they need a sufficient amount of force which can attract a upward force or a buoyancy force. Okay, then and only then it can be sink in the water. Now the upward force exerted by the water on the bottle is called upthrust or buoyant force, okay, which we said as a buoyant force or a upthrust force. Okay, in fact, all objects experience a force on the buoyancy when they are immersed in the fluid. The magnitude of this buoyant force depends on the density of a fluid. It is totally depends on the density of a fluid. Okay. So, why the object float or a sink when placed on the surface of water? A nail sink, okay, which we know it. Okay. The force due to the gravitational attraction of the earth on the iron nail pull it downward. Okay, what? Okay, force which are exerting, okay, they will pull a nail in downward direction, and due to which, okay, it will sink. There is an upthrust of a water on the nail which pushes the it upward, but the downward force acting on the nail is greater than the upthrust of the water on the nail, so it will sink. Okay, once again I am repeating. Okay, nail have a high, okay, pressure, okay, downward force. Okay, nail is exerting a force in a downward direction. In same way, water is exerting its own upthrust force or beyond force in the upward direction. Okay, but here in this case you can see that nail are applying a much more, okay, force in a downward direction. Okay, downward force of the nail is greater as compared to a upthrust force of a water, and due to which, okay, nail will sink. Okay, why? Because downward force is greater as compared to upward force, and due to which nail will go in a downward direction. Okay, and the phenomena is said to be a sinking. Okay, so nail is sinking. Okay, so in this case you can see that nail have a high downward force, okay, as compared to a upward force of a water. Okay, so here you can see that nail is sinking. Okay, but the cork float. Why? Because cork do not have a higher downward force, okay, as compared to the water. Okay, so the cork float while the nail sink. This happened because of the difference in their density. Okay, because their density is also different. The density of the substance is defined as the mass per unit area. Density is equal to what? Okay, mass upon volume. Density is equal to mass upon volume. Okay, so the density of a coke is less than the density of a water. Okay, if we talk, then density of a coke is what? Okay, is less as compared to a density of a water, and this means that the upthrust of a water on the cork is greater than the weight of the cork. Okay, so it will float. Okay, cork will float. The density of an iron nail is more than the density of a water, and here you can see that density of what? Okay, density of a nail is greater as compared to a density of a water, and this means that the upthrust of a water on the iron nail is less than the weight of the nail, so it will sink. Okay, therefore object of a density less than that of a liquid float on the liquid. The object of a density greater than the liquid sink in the liquid. Okay,
you pushing a box, your weight, which is a force acting downwards, hammering a big nail into the ground. All these forces, if you notice, are acting perpendicular to the surface. A force exerted by an object perpendicular to the surface is given a special name. It's called thrust. It's the total force acting perpendicular to the surface. What will be the unit of thrust in the SI system? Can you guess? You should have got this one. Thrust is nothing but force. So the SI unit of thrust will be the same as that of force. Newton. The SI unit of thrust is Newton. What's pressure? Now I don't want the definition or the formula. I want you to understand it. Let me give you a couple of examples. Take a pencil and keep it between your thumb and index finger, with the tip touching the index finger and the other end touching the thumb. Now apply equal force from both ends towards the pencil for a few seconds. Release the pencil and observe the two fingers. To be precise, observe the depression you see in the fingers. You'll notice that the depression in your index finger is much more as compared to the depression in your thumb. Why does that happen? Before we answer that, let me give you a second situation. When you stand on loose sand, you see that your feet go deep into the sand. Now, if you lie down on the sand, will you go just as deep into the sand? No, you won't. But if the force exerted in both the cases is the weight of your body, then why is the depth in the first case more? That's where the concept of pressure comes in. Pressure is nothing but the force per unit area. If we're talking about thrust, it would be thrust per unit area. If the thrust is constant and the area is more, then the pressure will be lesser. And if the area is less, then the pressure will be more. Pressure is inversely proportional to the area on which the thrust is applied. Now we can understand the two situations in terms of this formula. What happened in the first situation? As we apply an equal force from both ends, then as per the Newton's third law, the pencil will also apply an equal and opposite force on the fingers. But the depression was more on the index finger. That's because the area on which the tip of the pencil applies a force on is lesser as compared to the area on which the other end of the pencil applies a force on. As the area is lesser, the pressure is more, and that's why the depression is more. Can you understand the second situation using this concept? In the second situation, the area on which your feet lie is lesser as compared to the area on which your entire body lies. And that's why the pressure is more when your feet are on the sand as compared to when your entire body lies on the sand. which explains why the depth here is more. What is the SI unit of pressure? As its force over area, it would be Newton per meter squared. This is the SI unit of pressure. And this is also called as Pascal. 1 Pascal is 1 Newton over 1 meter squared. This has been named after a famous scientist called Blaise Pascal, who had conducted extensive studies in this area of science. Let's quickly recap what we learned. What's thrust? It's the total force acting perpendicular to the surface. And what's